looking at worksheet 4 from Unit 16. Number 4, what value of k makes it continuous? Well, the spot I'm worried about is 1/2. That's where it jumps from branch A to branch B. And so what we want to see is, well, like, is it really a jump, or are they like connected? But this says make it continuous, so I want it to be connected. So I need the y value of A at 1/2 to equal the y value of B at 1/2. So I sort of need A of 1/2 to equal B of 1/2. That way they'll be tied together. So for branch A, k times 1/2 cubed minus k times 1/2 minus 1/4. And for branch B, 16 times 1/2 squared minus 2. So that would be k over 8 minus k over 2 minus 1/4 equals, let's see, half squared is 1/4. 16 over 4 is 4. 4 minus 2 is 2. Alright, let's make all those denominators go away. So what could I multiply through by that would cancel an 8, a 2, and a 4? An 8. So I got to distribute the 8 to everybody. Common mistake, make sure that 8 gets to the other side. Alright, I'm going to do this once just because somebody's going to mess it up if I don't. I'm going to show distributing the 8 to everybody. I suspect most of you would not write this step out, but some of you need to write that step out. And there's nothing wrong with that. If you need to do it, do it. So k minus 4k minus 2 equals 16. Now we have a much easier problem to deal with rather than all those fractions. So negative 3k equals, k minus 4k is negative 3k. If I add 2 to both sides, I get 18. I'm worried because I don't see the answer there. Oh no, I do. I was looking for 18 over negative 3 and didn't see it. But 18 divided by negative 3 is negative 6. You got to reduce before looking for the answer. Good question. There's one like that on the test. You set the two pieces equal to each other and then have to find what k is. Haven? Yes, but is there a question on number 4?
Just like in general, so I'll wait.
Okay. Anything on number 4? Number 7. Okay, very similar setup, but now instead of making them equal, we're asking, are they equal at 3? So again, these two branches, I don't really know what's going on, but let's see, it's branch A when we're less than 3. It's branch B when we're more than 3. So I need to know at 3, like, what is going on? Are they, I mean, this is just a complete guess, but I need to know, are these two things equal? Do they match up? So A at 3, question mark equals B at 3. That's what we're trying to find. So number 4, we forced it to be equal and solve for k to make it work. Here, there's not a k involved. We're just going to see if we get the same thing or not. So A at 3, although if I plug in 3 in A, I get 0 over 0. But let's back up a second. Let's do x minus 3, x plus 3 over x minus 3. What's going on at x equals 3? What does that mean? There's a hole there. But that's okay because we're not really we don't make it to 3 for graph A. So I plug in 3, I get 6. And for B, 3 squared minus 3, 9 minus 3 is 6. So they are equal to each other. So my picture's not right. A has a hole there, but B sort of fills in the hole and takes off from there. So maybe something like that. So wait a minute, I guess I need to answer the question. Determine if it's continuous. So what's the answer to your question? Yes. I remember now that's not a super common mistake, but to do all of the work, like kids in calculus do this. They do all the work, they get all the right stuff, and then they don't. If you don't put yes, then you haven't answered the question. And I'll give you most of the points because clearly you knew what you're doing, but I can't give you all the points until you say yes, they are continuous.
If you just wrote continuous.
That would be fine, yeah. Good questions. Other questions? Then let's jump to the review. Were you here yesterday?
No, I wasn't.
You bet yesterday. It's review for the test Thursday. All right, looking at the review.
56 and 59.
56 and 59. Well, that looks terrible. Both of those. Well, 56 especially. 56. Let's see. E's and natural logs. Well, what's our always the first go-to for a limit problem? Just plug it in and hope that it works. It rarely does because we want you to do all these other tricks and stuff, but occasionally one is rigged to work. So let's plug in 2. E to the 2 minus 2, that would be e to the 0. And what's e to the 0 equal? 1. Anything to the 0 is 1. And then the bottom, natural log of 2. I don't really know what natural log of 2 is, but I start looking at my answer choices. Oh, well there it is, 1 over natural log 2. So it looked ugly to begin with, but it turned out to be okay.
What would we do if it didn't work?
Well, so the question is, what would we do if it didn't work? My question would be, well, how doesn't it work? Because there's different ways of not working. If it's 0 over 7, that's 0. If it's 7 over 0, that's infinity, but then you got to figure out whether it's plus or minus. And then if by not working you mean 0 over 0, that means we have to try one of our algebra tricks.
So yeah, how would we get rid of the log?
We don't have the algebra tricks to handle this. So if this one had been 0 over 0, we would have been stuck. Let's see, there were 3 tricks. There was factoring, there was fractions, and conjugates. So yeah, we don't have the tools yet, if that one had turned into 0 over 0, to do anything with that. There's one other big time trick in calculus, but we don't know it yet. Makes all these other tricks not even worth your time. But the calculus trick involves calculus, so we can't use it yet. There was another one, Crystal, 56 and 59. Which of the following is continuous at x equals 1? Oh, 3 problems in 1. Okay, so at x equals 1, the function is 1, but this first one, if we plug in 1, we get 0 over 0. So that's one of our tricks. So let's factor Roman numeral 1, or at least Roman numeral 1 part A. X x minus 2, x minus 1 over x minus 1. The x minus 1's cancel. So if we plug in 1, well, hold on, that means there's a hole at x equals 1. That's why this says x can't be 1. So we need to figure out if point B, which is just the point 1, 1, fills the hole that part A created. So how do I find the y value of this hole? Plug it in. So version A is x minus 2, except there's a hole at 1. If I plug in 1, I get negative 1. So that means there's a hole at 1, negative 1. So whatever this looks like, there's a hole at 1, negative 1. Does point B or part B fill in the hole? 1, no, because that dot's at 1, 1, so that'd be up here somewhere. So Roman numeral 1 is a no, not continuous. It had a hole and it was not a filled in hole. Roman numeral 2. Again, the problem area is at 1, so I need to check branch A at 1 and see if that's equal to branch B at 1. So 1/2, 2 plus 4 plus 1. Half of 6 is 3. 3 plus 1 is 4. I plug in 1 to B. 5 minus 1 is 4. So yes, that one works. So Roman numeral 2 is a yes. I wonder if that's enough to answer the question. So 1 is out, so I can rule out anything with 1. 2, 2 and 3. Okay, not none, because at least 2 works. So yeah, I got to do Roman numeral 3. I can see already if I plug in 1, I'm going to get 0 in the bottom. And if there's a 0 in the bottom and it's not piecewise, so I don't really care if it's a hole or an asymptote. It's going to be discontinuous there. X can't be plus or minus 1. And so without factoring, I don't know if it's a hole or an asymptote, but it doesn't matter. If there's a hole or an asymptote, it's not continuous. Now, I'm just kind of curious. So, in fact, it does cancel. But so what? That means there's a hole there, and nothing is filling the hole in, so not continuous. So only number 2. That was a good question. Let's back up and do 58 in just a minute.
So if there's an equation that like obviously does not have a hole in it, you just make them equal to each other and that's how you solve this?
Right, like this one, neither one of those have a hole.
Okay.
So you just set them equal to each other. Set them equal to each other at the breakpoint, or the potential breakpoint, to see if they're different or if they're tied together. Or the other type question is, make them equal to each other and figure out what k is. Let's answer 58. For what value of x does f have a discontinuity? Well, they were kind. It's basically already factored. Okay, so the x's cancel. What does that mean? If a value cancels, what's going on there? There's a hole. X minus 4 cancels, so there's also a hole at x equals 4. What about x minus 7? What's going on, or x plus 7? What's going on at x equals negative 7? What's What's happening if a factor at the bottom won't cancel? That's a vertical asymptote. But that's like more details than we need. Whether there's a hole or a vertical asymptote, all of those are discontinuous. So it's discontinuous at all of those places. So 0 and 4, there's a hole. -7, there's a vertical asymptote. But if all it asks is discontinuous, it's all of them. What's the fancy word for a discontinuity at a hole versus a? I don't know that I'm asking the question. Removable. If it's a hole, it's removable. Like if we cancel those out, we would remove the hole. The vertical asymptote is non-removable or unremovable or irremovable or whatever the right prefix is. A-removable? I don't know. Not removable. But this question didn't ask that. It just, so all we care is if it makes the bottom 0, that won't work. We're done. Um, 63 and 64. I don't think there was one like that on the homework, and there is one like that on the test. Prove continuity with the 3-step proof. I think that the test mentioned something about 3 steps, so that's a bit of a reminder. So the 3 steps for continuity is the function exists, the limit exists, and they're equal to each other. So step 1,
So we have to show the 3 steps.
you got to show the 3 steps. So function exists is step 1. So figure out what the function is, figure out what the limit is, and then step 3 is really easy. It's just does step 1 equal step 2? Well, that looks weird because 1 does not equal 2. Let me rewrite that. Does the function equal the limit? So f of 0. So if I want to evaluate this at 0, am I going to plug it in? So I'm not worried about limits. I mean exactly at 0. Is it going into part A or part B? B, because of the equal sign at 0. So 3 times 0 squared plus 3 times 0 plus 2 equals 2. So there is a function at 0, it is equal to 2. Step 2. The limit means I need to check from each side. So I need to plug it into part A and part B and see if they're equal to each other. Well, B at 0 we just did. That was 2. But now I need to check A at 0. Although if I plug in 0, I get 0 over 0, so I need to do a little bit of work on part A. Let's see, the x's cancel. So if I plug in 0, I get 0 plus 4 over 2 times 1. 4 divided by 2 is 2. Again, this was branch A. So 2 equals 2. That means coming from branch A, coming from branch B, they meet up. And so the limit equals 2. And then step 3 is, did the two answers match up to each other? Like, well, yeah, 2 equals 2. F of 0 equals the limit. So we're good. Now, this one proved that it is continuous, so that's the big hint. Like, it works, just show that it works. 64 is the opposite, prove that it has a discontinuity. So it's still the same 3 steps, and one of those steps is going to break down somewhere. So let's do 64 while we're here. So the 3 steps: function exists, limit exists, and they're equal to each other. So f of 7. Does that go in branch A or branch B? Branch B, because x equals 7. In fact, it's only branch B at 7. So 14 minus 1 is 13. So the function exists. There we go. Haven?
What's the third step on the one above, on 63?
It's just function. Does the function equal the limit?
So what do we write? We just write like 2 equals 2 for that? Or like what do you want?
I would rather you write function equals limit like this.
Okay.
But you're right. If you wrote 2 equals 2, I would be okay with that, because clearly you're saying step 1 equals step 2. We're good.
Okay, so literally just write function equals limit.
Yep.
So if it doesn't,
Well, let's see what happens, because something's not going to work on 64 because of the discontinuity. So let's work through the steps, and it should fail somewhere. All right, step 2 is the limit. Okay, but if I'm coming from the left or I'm coming from the right, this one's kind of tricky. If I'm coming from the left, so if x is a little bit more than 7, what branch am I on? A or B? If x is a little bit more than 7. From the right, so x is greater than 7. Which branch is that going to be on? A or B? If x is 7.001, that's branch A, because it's not 7. So I'll need to check branch A for the right. How about from the left? If x is less than 7, if x is 6.999, what branch would we be on? A. This is weird because branch B is not really a branch. We only use B when x is 7. If x is anything other than 7, we're on branch A. So x plus 7, x minus 7, all over x minus 7. X minus 7's cancel. And basically I can plug in either one because they're both really close to 7. They're headed toward 14. So the limit is 14. So the limit exists, so we're good. I mean, for step 2 anyway. Step 1, the function exists. It's 13. Step 2, the limit exists. It's 14. Step 3, does the limit equal the function? No. And here's where you could write 13 does not equal 14. If you want to be a little fancier, you could say f of 7 does not equal the limit. So not continuous. To try to make sense of this, if we did a graph of this thing, it would be the graph of x plus 7. Except when we get to 7, there's a hole. And whoever wrote this equation, when you get to 7, you plug in 7, you end up at 13. So branch A, branch A, branch A, branch A, branch A, branch B, branch B does not fill in the hole. And it's not continuous. So that's sort of the graphical understanding of it. But the official proof is function exists. Yep. Limit exists. Yes. But they're not equal to each other. Question? Well, what can you ask to help clarify?
We don't understand like the from the right, like from the left. Like I don't understand what that's from.
So I want to know the limit. So I need to plug in something a little less than 7 and a little more than 7 to check the limit. But this one's kind of weird because a little less than 7 or a little more than 7, either way, we're on branch A. Because Branch B is only true when x is at 7. Most of the time, less than puts you on one branch and more than puts you on the other branch.
So, because it's not equal to 7, it can be less or more?
Correct. So if we plug in 6.99999, we're on branch A because we're not at 7. If we plug in 7.000000001, we're still on branch A. We only get to use branch B at one point when x is 7.
I'm not using this because it's saying prove that it's discontinuous.
It says prove that it's discontinuous. So it's still the same 3 steps, but we know ahead of time that one of these steps is not going to work.
Yeah, so we're not using B because
We're not using B for step 2. We only need part A. Because the limit means as x gets close to 7, it doesn't mean x gets to 7. It just means as x gets close to 7. Well, if we don't get to 7, then we don't ever get to use branch B for this limit. Usually, like in number 63, we have to think about coming from the left and coming from the right. So we're on 2 different branches and we're seeing if they meet. 64 is not that because branch B is not really a branch, it's just a point. Better, worse, a little better. The test has a ton of questions like this first page. I don't think the graph is the same, but the questions are similar, and they're also in groups of 4 where it's a left limit, a right limit, an overall limit, and then the function. So at -7.
On the questions where the answer is infinity or negative infinity, that's always D.
Okay, let's do number 1 through 4 because it'll answer that question about D and E. So limit as x approaches 7 from the left. So as x approaches -7 from the left, what would your answer be here? Well, it's not negative infinity because it's going up. So I would accept either one of those. And which means, since they're both going up, -7 from the right, also positive infinity, which also means D and E. And the overall one, this is where it gets even more confusing. It's like, well, they're both going up, but for the limit to exist, that means they have to be equal to each other. But you can't really say infinity equals infinity. That's not really true. So there's another one where I'll accept either one. Yeah. How about f of -7? There should be no argument about this one. There is no function at -7, so that's a definite D and E.
So, besides like this type of like section of questions, would the rest just be like multiple choice, or would it be?
It's some of both. There's some free. It's exactly like this.
Right.
There's some that are free response, and then there's some that are multiple choice. What we haven't done yet today is from the left and from the right. So like number 48 and 49. Let's look at those. So what is our first go-to on any limit question? Plug it in. And really the first plug-in, you don't even have to worry about the minus and plus. 2 minus 2 over 2 minus 5. So that's 0 over -3. What's 0 over -3? That's 0. So the left-right thing didn't matter for that one. For 49, if we plug in 2 minus 5 over 2 minus 2, we get -3 over 0. Okay, that's a different ball game, right? Because this is okay versus no. So it's no, it's an asymptote, it's infinity, but I got to figure out which infinity it is. Well, 2 from the left, so what's something a little less than 2? 1.999999. So negative 3 divided by almost 0, but is it more than 0 or less than 0? Is it a positive 0 or a negative 0? Which is a really weird question to ask. But it's a little more than 0. So negative 3 divided by a little more than 0. Which one are we headed toward? Positive infinity or negative infinity? Negative infinity, because negative divided by a positive is negative. So the 0 in the bottom makes it infinity, and then the signs make it negative infinity. Which sort of means D and E, but D and E isn't an option, so we wanted you to specify positive versus negative.
So does it really mean the top, like the sign of the top? Because I don't know, a positive 0 is not really.
So you can end up with, if this had been 2 from the right, then this would have been 2 minus 2.001, which would be 0 but a little less than 0,
Okay. So then it would be positive.
and then it would have been a positive infinity.
And
So it's not just the top.
So because it's coming from the right, it's going to be a little less than 2.
So this one's from the left, though. The minus sign is from the left. So a little less than 2,
Would be the left.
which makes this positive.
Okay.
I don't see very many other left and right problems where you have to plug in a little more than, a little less than. Ooh, 42 to 44, there's our fraction stuff. 45 to 47, there's the conjugate stuff. I bet there's factoring in there somewhere. Yeah, 19 would be factoring. Because initially you get 0 over 0. And then if you factor, x minus 5's cancel. Then you can plug in the 5 and get 7 over 10. That means there's a hole there, but the hole's at 7/10. Alright, there's just a lot going on. There's graphical stuff. Usually once you get the hang of that, it's easy. But you got to get the hang of it. And then there's all the trick stuff. So factoring, 42 to 44, fractions, 45 to 47, conjugates, one-sided limits, limits at infinity. What do we do with limits at infinity? That's where you only care about the biggest degree term. 4x cubed over negative 12x cubed. What does that equal? X cubed cancels, reduces to negative 1/3. That's also the shortcut, but use the shortcut if you like, but it's better if you understand what's going on. That's the equal co part of the shortcut. Other questions? I will post the answers so you can check them. And test is Thursday.